Welcome to this lecture. In the last lecture, we had seen how to develop use case models, the graphical model, and also how to decompose the complex use cases using the three relations: generalization, specialization, and include and extend. In this lecture, let us see how to document a use case, because just the graphical model by itself does not convey the complete picture. It just tells about what are the use cases, and if they are decomposed into some use cases, who are the actors and so on, but details of the use cases are not given. And that is the reason why in a use case model, not only the graphical use case model should be given, but also the text description. As far as the text description is concerned, UML does not impose any standard way of documenting the use cases, but then some good practices have come up, and those are normally followed, even though there is no hard and fast requirement to follow the same documentation technique. Let us see how to document a use case. The documentation that is recommended by Alistair Cockburn in his Writing Effective Use Cases book says that every use case we must have the following documentation to accompany: the name of the use case, the actors that would use the use case, the trigger when the use case will start to execute, the preconditions, that is what must hold before the use case can be executed, the post condition, that is after the use case completes, what conditions must hold, the main line scenario. This is the typical interaction sequence between the computer and the user, and the alternative flows. We will see what are the different scenarios and what is the mainline scenario, the alternative flow, and so on. In every use case, there is a normal interaction between the computer and the user, and sometimes there are alternative flows. Let us take an example to explain this. Let us assume that we have a bank ATM. Let us take the case of a bank ATM. The user goes to the bank, inserts the ATM card, and then the system prompts for the password or the PIN code. The user enters the PIN code, the computer prompts, do you want to withdraw from savings account or current account? User chooses savings account, and then the asks for the amount. User enters, let us say 2000 rupees, and then the system asks, do you want a printed receipt? And the user enters yes, and then the cash is dispensed and the printout is generated and the use case terminates. So, that is like a mainline scenario, but then sometime the user when it prompts to the user, please enter the amount, the user enters 550 rupees, and then it prompts says that please enter in multiple of 100 rupees. So, again the user enters and so on. Sometimes as it enters 2000 rupees and then says want a printout and so on, but then the system generates a message out of cache and it terminates. Sometimes it proceeds and the amount is entered and it says that account does not have sufficient balance and it ends and so on. So, the main line scenario is the typical interaction sequence between the user and the computer. The alternate scenarios occur, but these are not so frequent. The frequent case is the main line scenario, but then there are other scenarios which we call as alternate flows or alternate scenarios may occur. While documenting a use case, we need to document not only the main line scenario, but also the alternate flows. Let us see how do we go about documenting that. Let us take the ATM money withdrawal example. Here document the actor is the customer. The precondition is that the ATM must be switched on, ready state to accept transaction. ATM must have at least some cash it can dispense, otherwise it would be displaying out of cash. ATM must have enough paper to print a receipt. So, this is the precondition before the user can start to interact. The post condition is that the current amount of cash in the user account is the amount before withdraw minus the withdraw amount. So, if the use case completes successfully, the post condition says that what must hold true, that is the amount in the balance in the customer's account will be the amount before the withdrawal minus the withdrawn amount, and the receipt was printed on the withdraw amount. And here we list the main line scenario and the alternate scenario. The different scenarios basically are interactions between the actor action and then there is a corresponding system action. The customer inserts the debit card, the system verifies customer ID, the customer chooses withdraw, system asks for an operation type, the customer enters the cash amount, the system asks for withdraw amount, the system checks if withdraw amount is legal, system dispenses the cash, system deducts the withdraw amount from the account and system prints a receipt. The customer takes the cash and the system ejects the cash and the card. This is the main line scenario, but then there can be several alternate scenario. Let us see how do we document the alternate scenario. In the step 3, the customer authorization fails, then the customer has entered a wrong PIN code, then display an error message, cancel the transaction and eject the card. So, this is one alternate flow. Another alternate flow can occur at step 8, the customer has insufficient fund in the account, display an error message and go to step 6. Step 8, customer exceeds the legal amount that can be dispensed per customer, maybe 50,000 is the legal amount, the customer entered 55,000, display an error message and go to step 6. There can be exceptional flow of events, for example, while the transaction is going on power failure and then the transaction is cancelled and the card is ejected. Let us take another example of a use case and how it can be documented. So, this is a change flight in a flight reservation system. The actor is the traveler, precondition is that the traveler has logged into the system and selected the change flight option. The basic course or the main line sequence is that the system retrieves the traveler's account and the flight itinerary from the client account database The system asks to select the segment that wants to change, system asks the traveler for the new departure and destination information, and if the flight is available then do the change, and then the system displays the transaction summary. This is the main line sequence, and then there can be alternate sequences. If there are no flight available for the segment, then error message is displayed and so on. So, we just saw some templates for documenting use case, but UML gives flexibility in not following the exactly the same standard, same template. We can tailor it, but then the one that we discussed are considered as good practices, and many developers follow that. Let us see some guidelines for writing effective use cases. The use case is a document to be read by a large number of stakeholders, and therefore, it should be very readable. We have to use simple sentences, and we must have separately the actor action and the system action documented, because as you can see here, the system and the actor, their actions alternate. The system initially, the actor initiates, the system responds and asks for something, the customer enters it, the user enters it, the system responds and so on, and therefore, we must write it in the same way. What does the actor action and what is the corresponding system action? We should not mix that up, that get the amount from the user and give him the receipt. We should not club both of these. Prompt the user for the amount, the user enters the amount, then the system action is dispense the account and print the receipt. Also, we should not write trivial steps in the use case documentation. For example, the user clicks a key, that is not a progress, not a tangible progress in the use case execution. So, every step that we document for a use case must result in some tangible progress in the use case execution. Now, let us see that given a problem description, how do we identify the use cases? A popular way is to find out from the problem description who are the actors, and then for each actor we can find out what are the functionalities that the actor invokes, and then against that actor we had seen the case of the library software. We identified the actor as the member from the problem description, the librarian and the account, and then for the member we can identify the use cases that the member needs to execute, that is query book, issue book, return book. Similarly, the librarian create member, delete member, create book, delete book, check fine, etc., and the account check the current balance, enter book procurement price, and check the fine collected and so on, membership fee collected and so on. So, this is a popular way to find out what are the who are the actors, and each actor needs to invoke which functionalities. The second way is a event based, where we identify what are the invocations of the system, what events the system must respond to, and then we relate these events, who generates these events, and then what are the use cases that execute. So, for some systems like let us say the embedded controllers and so on, it is easy to identify the events based on the state machine specification of the controller, and then relate who are the actors who would generate that event and what is the corresponding use case. So, for some systems like embedded controllers and so on, event based may be preferable, but then the actor based one is very popular across all systems. Now, let us see one example. This is a course registration software. Let me just read the description of the software and let us see how do we go about identifying the actors, the corresponding use cases, and then document it. At the beginning of each semester, each professor shall register the courses that he is going to teach. So, into the software, each professor will enter the course details that he is going to teach, and then once the professors have entered their courses they will teach, the students can select up to 4 course offerings, and during the registration a student can request a catalog showing various course offerings for that semester. Information about each course, professor, which department, what are the prerequisite would be displayed as part of this catalog. The registration system sends information to the billing system once the student completes registration, so that the student can be billed for the semester based on which courses he is taking. For each semester, there is a time period during which dropping of courses is permitted, and the professor must be able to access the system to see which students have signed up for their course offerings. How do we go about developing the use case diagram for this problem description? We need to identify the actors, which is very easily identified. Here it says that the professor shall enter the course details. So, the professor is an actor. The student can select up to 4 course offerings. The student is an actor, and the registration system sends information to the billing system. The billing system is an external software, may be running on a different computer, or at least it is a different software, and this is also an actor. So, we can start identifying what are the use cases that each of these actors can invoke. The professor can register the course detail. The student can select course offering, and during the course offering, during selecting a course, he can request for a catalog. So, this is optional. He may or may not request a catalog and looks like an extension. So, course catalog is an extension of the use case which is registered for courses. For each semester, there is a period of time during which dropping of courses is permitted. So, the dropping of course is a use case for which the student is the actor, because the student initiates it. But how do we represent that there is a period of time during which dropping of courses is permitted? When there is a element of time here, we need to have an external system which is a calendar or a time. That is the typical convention, even though it is the system time. But if we represent a calendar actor or a timer actor, time actor, then the design process becomes simpler. As we proceed, we will see, but then at the moment whenever there is an element of time, we will have another actor which is a calendar, and this is a use case which the professor will access to find which students have signed up. Now, let us see, this is the overall diagram that we discussed. Now, let us see how do we draw the diagram. So, this is the diagram. The professor registers the course offering. He can find out how many students have, which students have registered, and the student can register for courses which is less than 5 courses. We just write here in the form of a constraint on this line, the communication line, and during the course registration, on successful registration, the billing system is sent information to generate the bill, and we have written here external system, the billing system. And for dropping courses, there is a time limit, and we have the calendar as an external actor, and then we have written the constraint here if today is less than set date. So, as long as the deadline is not passed, the student can drop a course. Scott Ambler in his book in 2005 gave some style notes how to document a use case well. All use cases must be verbs, and even though when we document the different use cases, even though we can document that in any order, but according to Scott Ambler, as far as possible, we must have an ordering of the use cases in the diagrams, and that should correspond to the order in which these use cases are invoked. That helps in understandability. For example, first is query book, issue book, return book, and so on. We must order the use cases from top to bottom to imply timing wherever possible, and the primary actor must be on the left. For example, if the student is registering for the course, the student initiates the registration, this is a primary actor, whereas the external billing system is a secondary actor. The primary actor must appear on the left, the secondary actors must appear on the right. The relation between the actor and the use case drawn by just a line, these do not use an arrow, and whenever there are time, we must have a time or calendar as an external actor, external system which is the actor, and if there is a interaction between two customers, for example, the user gives some information to the clerk and the clerk enters it, we do not have to show that. We need to only represent the information that the actors input to the system. The interaction between actors we do not have to capture here in this diagram. And when decomposing the use cases, the complex use cases, we should not decompose into a very deep nested sequence of use cases. The include and extend should be rarely nested to 2 level deep. The use case names should be in the perspective of the users, we should use the users language. The use cases should be simple to understand, and this can be decomposed wherever required. And also remember that these are requirements, the use cases are basically functional requirements, and just like the requirements, they focus on what aspects and not how or the design aspect. Same holds for the use case diagrams as well. We should not have a use case diagram that has too many use cases, that becomes very confusing. When we have a situation where we have too many use cases, we should use packaging. In use case packaging, we use this folder symbol, which is supported by UML, and related use cases we can put inside the package, and we write the name of the package here. All the use cases pertaining to the accounts actions, for example, printing the balance sheet, making payment, receiving grant, etc., these are in the accounts package. We can use the packaging to reduce the number of use cases in a use case diagram. Just see here the same one, we can just have the ordering here, the ordering as one of the package, the ordering related use cases are here, the customer maintenance related use cases are here, and then in a separate diagram we can show the use cases in the ordering, and that makes the diagram easier to understand. So far we have been looking at the use case diagram, that is a crucial diagram, but it is also one of the simplest diagrams to develop. But then it requires little bit of skill with respect to identifying the use cases, with respect to decomposing the use cases, the documentation of each use case, and request you to please practice some of the assignments that we will give on developing the use case diagram to specific problems, because just by understanding the concepts here, you may not get the expertise to develop a use case model. We need to practice on several problems to develop the expertise of developing good use cases. Now, let us look at the class diagram. We know that classes are entities with common features. These have attributes and operations. Each class can be instantiated into objects. All objects have the similar attributes and operations. The classes, this typically accepted that these are solid outline rectangle with compartments, and the compartments are name, attribute and operations. But we will see that there are various ways of representing the class diagram. For example, we might just write the name of the class, we might write the name and the attribute in two compartments, or we might write all the name, attribute and operations. We are almost at the end of this lecture, and in the next lecture we will discuss the class diagram in more detail, how to document a class diagram, the class relations, and how do we represent that in a class diagram. We will discuss in the next lecture. Thank you.